What's everyone doing? It is the final uh, assignment for your stats course. So we're going to look this time at some non-parametric tests, specifically two different types of chi-square tests: the chi-square good as the fit and chi-square test of independence. So for this one, you work at Hoopty Car Rental, and your manager wants to know two things. Are there some types of cars, economy, standard, luxury, that are rented more frequently? Secondly, do men and women rent different types of cars? That is, do they prefer economy standards and luxuries differently? So the data are shown here. This is called a cross tabulation. You can see there's two variables involved. Um, and there are three different types of cars, and there are two sexes. So for the first question that your manager wants to know, basically, do we rent economy standards and luxuries differently? So at different rates, different frequencies. Those counts are 34, 29, and 37. Those are the numbers we're going to be comparing. Now, to do this, we're going to do a chi-square goodness of fit test. That's under Analyze, non-parametric tests, down to Legacy Dialogues, and then chi-square. And when this opens, we simply need to put car type over in the box on the right. We then need to tell it, hey, where should it get the range? What is the expected range? Get it from data or expected values, all categories being equal. Well, if indeed of the 100 cars that we rented, that we were renting the same number of each time, 100 divided by 3 would be 33, 33, 33, which is impossible because you 0.3, because you can't rent 0.3 of a car. So the question really is, are these things different enough from chance that we believe that there is really a difference? They prefer one type of car more than another. So the expected range is get from data, expected values, all categories equal. Those are correct. Click OK. That gets the analysis we need. And there's not much to it. So question one, how many car types are being compared in the chi-square? Is this a fit test? Well, there's three of them: economy, standard, luxury. So three is your answer. We need to fill in our hypotheses, and these ones are always pretty darn easy because they're always two-tailed. It's always equal in the null and not equal in the alternative. So equal and equal, not equal, not equal. That's what we got here. What is the expected frequency of each car type out of 100 if the null hypothesis is true? I just told you guys it's 33.3 because we rented a total of 100 cars, but good news is the SPSS calculates at 40, so it's 33.3 is the number of each type of car we would have expected to rent if the null hypothesis is true. That is, their categories are all equal. All right, so then we're going to write the residual. The residuals are literally that number minus that number gives you that number. That's what you get. So there was, I don't know, 0.7 of a car fewer economies, or more, sorry, 4.3 fewer standards and 3.7 more luxuries. So are these big enough for us to say, yeah, something crazy is going on here? But anyway, 0.7, negative 4.3, and 3.7 are your residuals, differences from expectation. Um, using the test statistics output table, this guy right here, and the decision rule above, should the null hypothesis be rejected? Well, there's our sig right there. It is definitely not less than 0.05, so we are not rejecting anything. So the only requirement is that sig's less than 0.05, and no, it's not. So no, why not? Sig, that's what they call it. Asymptotic is what it means, if you care, is greater than 0.05. Next thing we need to do is get our measure of effect size, and we got to calculate it. So it's a little complicated. You got to get chi-square on the top, and it's already chi-square, so you don't have to square chi-square. On the bottom, it's n, total number of sample size, so 100 times k minus 1, or number of categories of cars minus 1. So it's on the bottom, it is 100 times k minus our 3 minus 1, so 2. So it's 200 on the bottom. So let's do that. And again, for those who got confused, I'll just do the bottom real fast. It's 100 is the total number of cars we rented. And remember, this means multiply by. So it's times 3 minus 1. So that is 2. We get 200. So let's do this. Our chi-square value is 0.98. So 0.98 divided by 200 on the bottom. That gives you that. And then you take the square root. So it's 0.07. That is our measure of effect size. About 3% of the variability in the cars rented can be accounted for by the type of car. Let's fill in our chi-square now. We have a chi-square with 2 degrees of freedom right there. N was equal to 100 cars that were rented total right there, was equal to 0.98. Our P was greater than 0.05, and our V was, for Kramer's V, was equal to 0.07. That's what we calculated right there. So things were not significant, but if they had been significant, we would be looking where the big differences were according to the residuals. So what's this all mean? Well, the interpretation for number 8 is we want to answer our boss's question, whether some types of cars are rented more frequently in response to the manager's first question. Nope. Even though it's not perfectly equal, it's basically equal. So no, we rent all 3 types of cars about the same or similarly. So for your boss's second question, do men and women rent different types of cars or prefer different types of cars? That involves 2 nominal variables. So we need to use the chi-squared test of independence for that one. So that's sex and car type, right? So we go to analyze, and this one's even a weirder spot. You go to descriptives, and then you go over, descriptives, and go to crosstabs. So analyze descriptives crosstabs, you get in here, you need to pick what's going in the row, what's going in the column, and I pretty much tell you here. So move car type to the row box and sex to the columns box. So it matches your APA write-up, by the way. So it's easier to write up is sort of the thought. In the click display clustered bar charts, you get a pick. And then we need to click up here under statistics. We need to pick chi-square and phi in Kramer's B. That's our measure of effect size. Then under cells, we got to get some stuff under cells. Already is going to give you observed, but I tell you, you should also get what was expected for each cell. And then under counts, columns, and percentages down here, we want to get either the row percentages or the column percentages. And there is no necessarily wrong answer, but one of the percentages usually sort of explains the relationship better. In this case, I tell you to go ahead and get the columns percentage. We also want to get adjusted standardized residuals. Those are kind of like z-scores that tell you, hey, something weird's in the cell. If the chi-square is significant, it helps you interpret things. So column, expected, adjusted, and observed was already picked. And continue and click OK. And we've got our second test, our chi-square test of independence. So this is the one where the hypotheses are written in words. And basically, the null hypothesis is always that these 2 variables aren't related, they're independent. So, and then the alternative is always, well, these 2 variables are related. There's some sort of difference or dependency. So, starting with the null, the null hypothesis, if indeed these variables are independent or not related, would be no, men and women do not differ in the types of cars they like to rent. Something like that. Some way of saying that. So I said men and women do not rent different types of cars. The alternative is the opposite of that. So men and women do rent different types of cars. So some version of that. All right, so of each sex, what percentage is rented each car type? So let's take a look at what we get here for our crosstab. Because we got column percentages, the columns all add to 100. If we had gotten row percentages, the rows would add to 100. So in this case, we're doing of males, what percent rented each type of car? Well, it was 42.0 for economy. Oops. It was 36.0 for standard and 22.0 for luxury. We got the same thing for women, 26.0% economy, 22% 0.0 standard, and 52% like those luxury cars. So, is anything going on here? Are we going to retain or reject the null? So we go down to the chi-square test table. You want to look at the one that's called Pearson chi-square. Scoot on over. If that is less than 0.05, we're rejecting the null today. And indeed, 0.008 is less than 0.05. So we will be saying, yes, we're rejecting the null. That is, there is some sort of difference in the cars that men and women like. That's what this tells us. We're rejecting that they're independent. So why or why not? Well, because asymp sig is less than 0.05. That's why we're rejecting the null. We got to calculate our variability, or the other way to do it is Kramer's V is actually printed right here. So we can just use it. So I don't know. Let me do it both ways since it's my job. So again, here's the formula for it. On the bottom, you've got number of cars rented, and then it's multiplied by the minimum of number of rows minus one or number of columns minus one. Whoa. All right. And that does not include totals. So there are two rows, or excuse me, two columns. So two minus one would be one. There are one, two, three rows. So three minus one would be two. So we do the minimum, which would be two minus one, the number of columns minus one. So the bottom here is 100 times the minimum, which would be one. So it's just 100 in the bottom. So to calculate Kramer's V, what we do is we get our chi-square of 9.653, 9.653, and we divide it by 100, because that's what we got down here, 100. And that gives you 0.09653, but don't forget to take the square root. 0.31. And indeed, if you look, sorry, anyway, the answer is 0.31. It is actually what SPSS gave us as well. So let's write our actual chi-square out now. We got a chi-square with 2 degrees of freedom, and that's not supposed to be italicized. God knows why you did that. There we go. Chi-square with 2 degrees of freedom is n equals 100. So there's 100 total cars that were rented. And this is also missing this. Okay, getting better. Is equal to 9.65 right there. Our P was less than 0.05, and our V, or Kramer's V, was 0.31 down here. About 31% of the variability in the car rentals could be accounted for by the sex of the renter. So for the post hoc tests, let's go ahead and look at the post hoc test. So to do post hoc tests, so because the chi-square is significant, the question is, well, who likes what type of cars? Grandma would want you to tell her. So to figure that out, what you do is you look at the rows in here that are called adjusted residuals, and you look where these are 2 or bigger. If it's positive 2 or bigger, it means there's more in that cell than expected. If it's negative 2 or bigger, there was fewer in that cell than expected. So economies, there's neither of these cells compared to each other are 2 or bigger. So they liked renting, or they rented economy cars about the same, men and women. All right, how about standard cars? For standard cars, again, neither of these are greater than or to absolute value of 2 or larger. So we would say men and women preferred standard car rentals about the same. All right, well, what's going on? Well, down here, the adjusted residuals are negative 3.1 and positive 3.1. These are absolute value of 2 or bigger. The negative tells you that fewer males rented luxury cars. The positive tells you more females rented luxury cars. So that's what we have to say is men and women didn't differ in their economy or standard preference, but women, because the positive, I would say, or you could, liked luxury cars more, or you could say men liked luxury cars less. So it's common to use the actual percentages as well. So we would say, yes, there's a significant difference in the types of cars that men and women like. Women like luxury cars, 52% of their total rentals, more than men at 22%. And that's right here. So hopefully you wrote this up and everything went okay. And congratulations, you made it through stats.